Welcome to the Treasury Update podcast presented by Strategic Treasurer, your source for interesting Treasury news, analysis, and insights in your car, at the gym, or wherever you decide to tune in. On this episode of the podcast, host Craig Jeffery speaks with Viola Hechl-Schmied, product owner for machine learning at Ion Treasury and product manager for Ion's Treasury product ITS. They discuss plans in a case study where Treasury and Treasury technology providers explore the use of machine learning. Listen into the discussion to find out more.
Let me give a quick introduction to our special guest, Viola Hechl-Schmied from Ion. And she started at Echo Finance and Reval and Ion back in 2010. She's the product owner for machine learning at Ion Treasury. She's also the product manager for Ion's Treasury product called ITS. She holds a Master's of Science degree in Financial Mathematics and Actuarial Mathematics from the Graz University of Tech. And she's the certified Scrum product owner from the Scrum Alliance. Welcome to the Treasury Update podcast, Viola.
Thank you for having me.
Let's get into some of the topics in the background on AI and machine learning, as we'll call it. So there's definitely been a lot of talk, chatter, and interest around artificial intelligence and machine learning. But before we get into some examples, which I know you want to share how people are using it, I'd love to hear how you define those two terms. Some people see machine learning as part of AI. Some people see them as slightly different. But how do you define each of these so that our listeners are understanding your definition of AI and machine learning?
Well, it is a highly discussed topic here. And for me, artificial intelligence is all about how we make computers do things at which at the moment people are better. So this is really a broad spectrum that is involved here. Not only actually computers doing computations, but might also include robotics, for instance, or natural language processing, as we know with artificial personal assistants, as we know today as Siri, for instance. And machine learning, therefore, is actually a subset of artificial intelligence where we focus highly on teaching computers, for instance, learning a certain mathematical function that is actually not really aware of what it is learning, but it can learn the outcomes and then, for instance, also forecasts them. It can learn many other stuffs, as, for instance, categorization. So within this machine learning area, a lot of statistical applications are actually located, some statistical methods. And it even gets further that within this machine learning, the so-called deep learning is very popular at the moment. So if you go down, you say on top there is artificial intelligence. Within this area, we find machine learning. And within machine learning, there's a subset called deep learning, where we find, for instance, neural networks that are very popular today and get a wide audience nowadays with several different application areas that can be done with neural networks.
So maybe you could just give a quick explanation of neural networks as well, as part of deep learning. What is a neural network?
Well, a neural network it can learn actually any mathematical functions, for instance. It is not restricted to a certain characteristic of a function, and it can do even more. It can also perform classification problems, for instance. It can do picture recognition. So if a neural network takes in as an input a certain input value, this could be a picture, this could be a number, this could be text, this could be lateral language, actually, and it processes it. An output is generated. It could be one output, could be several outputs. So the magic behind it is actually that this is a graph, if you want to say it in a more technical sense, a graph with weights attached to it. And the neural network, when it trains, so you have to train a neural network in order to really get it to understand what input creates what output. And during this process, it adjusts these weights that are used for calculations in between. And these are safe then. And it's like you might even say on a very high level, you could maybe compare it with a navigation map where you could use several ways to come to the same output, or you could use different ways to get to different locations, depending on what your goal is.
I guess that definition, the way you describe the neural networks, this process of learning as you go along, and training the computer, it's different from when you know how things are going to occur and you program the computer to say, here's the order of hierarchy here, here's what you do, and it's defined and it's rigid, and this sounds more flexible and adjusting, that learns from what the human's doing or learns from the interaction with the data. Is that accurate?
Yeah, it is. So, for instance, neural networks are very popular nowadays as they got a wide appearance with using Tesla car, for instance, because Tesla uses neural networks for image recognition and image processing, so that when the car is driving, it continuously captures pictures and runs them through this neural network, and it then identifies, for instance, whether you're approaching a traffic light. And then what further on, if it identifies this is a traffic light, it then actually knows, okay, now I do have to know what the traffic light is telling me. Do I have to stop? Can I go further? Or if I do want to cross, for instance, it processes the images and gets information back whether you can cross or not. And this is what is very popular with neural networks, picture recognition. But not only, you can use neural networks also for categorization, for instance. You could train it to identify whether a picture is a dog, a cat, or a bear. But you can also use it to identify, for instance, whether a certain insurance police is rather suited to be in under 25-year-old male or over 60-year-old woman living in a rural area or in a city area. So very different approaches can be done with neural networks.
Tell me how you got started in machine learning. Obviously, your background includes mathematics and the science of numbers, but how did you get started in machine learning?
Well, me personally, I was approached internally within the company that we would want to do that. And then I started online research, as lots of people do, and actually stumbled upon a book that I read through, which was really a good introduction into machine learning. A lot of blogs are out there that teach you a lot. It can be actually quite overwhelming what information is out there. So for me, it was actually a great thing that we did a research program together with the University of Technology in Graz on actual application areas of machine learning and AI within Treasury. So they identified certain areas where we could focus on, and within these areas, we picked the first use case. And getting into this field with a certain use case in mind makes it much easier, actually, as you really know what you have to search for, where you have to do research in order to get started. And then there are references to other areas, of course, where you can then can go from hundreds into thousands and so on. So this is how I got involved into the machine learning, actually.
In addition to learning about it, you partnered, if you will, with the University of Technology at Graz, and you came up with this list of ideas to work on things. How did you figure out how to rank these or determine what you would pursue to develop and learn in the process as you went through this?
Yeah, so the basis actually was one of our TMSs in the Ion Treasury portfolio, namely the ITS product, which we develop here in Graz, and this is our main product here. So with this in mind, we approached the university and explained them what we are actually doing, where we do have already kind of rule sets, for instance, in place that might be replaced by machine learning, or other areas where we think that a machine could help and add value. And once we identified them, we actually thought, where are we already quite good, even without machine learning, and where is actually a lack? of value for the client that we could fill with machine learning possibilities. And also, of course, what would be a quick win for us. So nothing where we would have to develop another 2 years, because we actually wanted to get it out rather sooner than later, to be honest. So this was also helpful in this case, and we identified in this case that the ITS product that we develop here, but also the Reval product of the Ion Treasury portfolio, and another product, the Treasury Services product, all include this liquidity plan. We call it liquidity planning, where you actually plan cash. And we have the possibility there to forecast, but rather simple, mainly like you can distribute the same amount over a certain time period into the future, but nothing else in place. So we thought that this would be actually a good starting point, really to add value to the client and to make his life or her life easier when it comes to daily work with the TMS.
So what did you do as you looked at this, applying machine learning in this area of cash forecasting or liquidity planning, I think is you're using the terms. What did you do to build this up and test it and figure out what to do with it?
Once we identified the first use case, we again got back to university and asked them, well, if you were confronted with this use case, what techniques would you suggest to us that are, on one hand side, easy to understand for the client? That's one thing that clients actually like, that they understand what the system is doing. But on the other hand, are actually good models that could really add value to them. So they came back with proposals for statistical methods, for instance, linear regression or ARIMA models. ARIMA stands for Autoregressive Integrated Moving Average, a very complicated word and actually a great concept. But also the possibilities for neural networks are here with cash forecasting. Then we decided, okay, that's actually a great idea, because linear regression is easily understandable by the client. It can also be rather easily implemented by a data scientist or developer on our hand side, and it's really hopefully getting a quick win. It's much better than saying, okay, distribute $10,000 for every month over the next 6 months, because it does consider the time series, the history of the data in the liquidity plan. And then a more complex model, a ARIMA model, for instance, might include not only a trend, as a linear regression might do, but it can also observe seasonality and incorporate seasonality into the model. And then we have like the Rolls Royce of the models would be the neural network, where we see possibilities to not only capture trend and seasonality as the classical statistical models, but also maybe track patterns that these classical methods could not track and incorporate them into the forecast, or might also be able to detect outliers and ignore them actually, because they would mess up a forecast. And this is how we approached it, and how we then actually started off with the simplest models first, and then added more to it, more models and more complex ones, in order to obtain good results that we now see.
That's interesting. So, especially as you talked about the simpler, like moving averages or to the linear regression, ARIMA, which I'm going to try to fit into conversations that I have, and then neural networks. Yeah, the one thing that popped in my head when you call it the Rolls Royce of models, I was thinking you were going to call it the Tesla of models, with given your example before, but I definitely get your point there. But as you look at what you did with cash forecasting, I think that's smart to do that. That was a smart one to do first, for all the reasons you gave about is there an opportunity, a lack, or is there ability to do a quick win? But it's also a huge area of focus for companies. We have a number of surveys that show that cash forecasting sucks up massive amounts of time, and it's hot on everyone's list, and there's value in getting it done more properly, done more accurately, more frequently. And so that seems like an ideal area. So where are you in the process, and then what were the challenges that you went through to work on bringing in machine learning and cash forecasting?
One issue is always the quality of the data available. So luckily, if we have a look at our existing client bases, most of the clients are with us a long time now, so they do have a good history of data available, which is essential for machine learning techniques, that you have a history as the models are trained on it. Another thing is, of course, regarding quality, what do you want to add to it? Because with simple methods, statistical methods, you don't really care if this value occurred on a certain day, for instance, or in a certain month. But for neural networks, it is of importance, because if you train a neural network simply based on a prior day value and the outcome is today's value, you don't get good results. You do have to consider more and there the question pops up, how much of history is actually relevant to produce a forecast? And then additionally, what else is there that is of importance? Is it important to know in which quarter, for instance, a certain value occurred, or whether or not there was public holiday prior to this value, whether or not there was Thanksgiving and then Black Friday as we had now, or Christmas? These are, for instance, for retailers, time periods where a lot of money is generated, and this of course should be incorporated into models. So data analysis on this level is crucial, I think, and for the clients also in this sense that they prepare the data accordingly. So during our talks with clients, we sometimes really found out that they do want to predict cash, and they might even have our liquidity plan at hand, but to really use it, they would need to go a step further and really categorize their cash accordingly in order to create better results. So cache categorization is also a huge topic in every aspect of TMS. Actually, cache categorization is very important. For instance, if you want to create a cache report according to IFRS, for instance, you do have to split it up, and a lot of clients do that already. Some have issues there. They could use maybe the implementation of a rule set, or maybe here again machine learning pops up. Maybe this can be another area, and we think it is a very important area to also introduce machine learning techniques, AI techniques for cache categorization. So of course, when you started, you use, let's say, artificially generated data, of course, when you try out your models, and this is during the alpha testing phase, and then you think, well, the model works quite well. Then the client comes in with beta testing, and we are able to actually use client's data, and then you really see whether or not a model is working good or not. So we did see that, I mean, statistical models, you can't really improve a linear regression, except you move to another kind of regression solution. Also a REMA model, we decided here actually to not go with one specific model, because ARIMA models do need parameterization. So we decided to not just use one model with a fixed set of parameters, but to use, again, hypothesis testing and other statistical tools available in order to determine the best fitting parameters for a time series in order to have ARIMA deliver a good result. So this is actually even a step further than you would typically do. And then for the neural network, we were able to then identify where we might need to adjust the input data, where we might need to adjust the neural network itself. So it does indeed help to really work with client data to see how its nature is and what that means for the techniques and for the models themselves.
You said a couple things there that made me want to ask a few more questions when you talked about what provides the best fit. So as part of your testing process is you create these different models and you have these hypotheses. Are you then back testing it on historical data to see how well it fits, or are you just running it as you go forward to see which of the 2, 3, or 4, or 5 models is providing you with better accuracy for cash flows or bounces?
Yeah, so for the ARIMA model, it's really that you first actually have to train the ARIMA model. So within this process, we look at historical data and try out different parameter sets and determine the one set that returns the best result for this time series. The neural networks work similar. So you train it with historical data and it goes through various iterations where it tests on this data and determines the best weights for the model. Additionally, for neural networks, what you can do and what we decided to do is to split off a certain percentage of your training data to have it as a so-called validation set. So you train on, like, let's say 75 or 80% of your data, you train on that, and then the remaining data you actually take for validation in order to see, well, is that what I trained actually applicable to data that the neural net doesn't know of because it wasn't trained on it. This helps improve the model, and it also prevents the model from so-called overfitting, where it really just learns the input data. It can do that very well. It can forecast this data very accurately, but then it might fail on any other data that you put into it. So I think this is also very important to do for neural networks to prevent overfitting.
A question on the this first use case that you've been talking about, the cash forecasting. What was the time period from when you started looking at cash forecasting as a model to going through all the process to it's in beta where clients are using it and learning from the system, select clients are using it? Was that when did you start? How long?
Let's say when we really started to look into it was last year, and then it took around 6 to 12 months, roughly speaking. It's a broader range because it went a little bit hand in hand. So we started testing with client data before we actually officially released it into our product.
Yeah, I think it's just good for people to know how long it takes for someone to go through that process and then get it to where it is today. But you started talking about cash categorization, and when we prep for this call, we had a little bit of a discussion on it. But maybe you could describe what you mean by cash categorization, because Treasury people categorize cash flows by cash positioning, cash accounting, bank reconciliation. You gave an example of IFRS, categorizing flows, whether it's operating, investing, financing type activity. Is this categorization across all of those, or is it focused on the cash position worksheet, for example?
It can be both, actually. So you can have a look at the cash position, and then I think in North America area, you are more focused on the cash position, maybe. I know here from Europe, especially from the Germany, Austrian region, that we work a lot with liquidity plans, which is actually, I think, similar. And you can use a liquidity plan to design any template that you like. So you can use it, for instance, to generate something that is similar or can actually then fill an IFRS cash flow report. You can also use it to use any categorization that you're interested in. So when I speak of cash categorization, typically what the client of ours is doing, he is receiving bank statements and then he's loading them into the system. And in order to always have visibility of his cash with all his accounts. And the items on the bank account statements should be categorized somehow, because then you can act further with them. Some of these cash items that are on the account statement are actually also generated from the TMS itself. If it is, for instance, used for administrating FX deals or loans and investments or bonds, for instance, where there are disbursements, interest payments, and so on. So you want to match these cash flows with your account statement item. So there are two use cases, if you might say, for categorization, cash categorization. So the first is you receive an account statement and you actually want to know what is on your account statement, what is each item, in order to then use it further in your TMS. So you receive something and it says somehow bond repayment, $50 million with the reference number from the bond, for instance. And then you know, okay, this is a repayment of a bond. And then you can actually map it with the according categorization that you have in your system and then process it further, because you could use it then in your cash position or in your liquidity plan and show that a certain amount of cash was actually dispersed, for instance, or in a specific month. If your planning was good, you should then see in your liquidity plan that you used for planning the same position and can see that it matches, because you knew, of course, that you had to repay the bond. Other payments are much harder to forecast, actually. Or salaries. You have every month you generate salary transactions, so you want to also include them, and it's typically easy to identify these. And then the second use case would be that you have an item, you might have categorized it already, and then there is a cash flow that was generated by the TMS, which is actually the same. And it might happen that for whatever reason, for instance, they differ in a tiny bit of an amount, or due to a holiday or so with the value date. And still you want to match them so that you know that the cash flow that the TMS generated is actually also part of an account, and it came in with an account statement, and they found each other and they are matched. So these are two areas where you can use cash categorization or matching. You can say also matching.
This is the second use case that you've been talking about, and I guess that's underway. It's moving. Is that in alpha testing or beta testing, or can you tell us where that sits?
Yeah. So again, with this use case, we are currently in the research phase. A little bit further, actually. So we had the first prototype implemented. This is another type of use case where you actually use natural language processing. You can approach it with different kind of ways. You could approach it with a simple statistical model, for instance, a decision tree, but language processing can also be performed and learned by neural networks. So we again are researching and spending time on developing a neural network that can also categorize cash according to text with a neural network. Because typically when you receive an account statement, there is a text attached to it, and it typically holds the information you need to categorize it. So it would not make sense to just know that on a certain day with a certain account you got a value, but you actually have to also include the text, because this holds the information that is vital here in order to categorize it correct.
Just to summarize the first part, cash forecasting is in client beta, and then the cash categorization is in prototype, and still doing research and learning, but it's in prototype phase. As we look at other future use cases that you're working on, should we realistically assume that you are working on or contemplating? I know we talked about a few things the other day, but what are some of the items that you'd want to share of future use cases in Treasury that may be coming down the pike?
I think there's a broad variety of use cases. We see that, of course, anti-fraud is always a highly prioritized topic. You can have anti-fraud in various areas of the application. First to pops up, of course, is payments, where you want to prevent erroneous payments or fraudulent payments. But also it could be amongst trading, for instance, erroneous trading that you do want to prevent, maybe to enter a wrong amount, which could have fatal outcomes afterwards. Or where we also see potential is maybe hedging of cash flow or FX exposures, for instance, or also investment proposals. So it could be that the system detects that you have overflow of cash somewhere, and it comes up with proposed investments that you can do with this cash, for instance.
Okay, so the last couple, the trading, the suggestions for trading or hedging or making investments, there's an optimization process there that it's helping and supporting. That seems like the second category.
It could be that, an optimization. It could also be that based on past actions that you did, that it might suggest you, hey, you typically do this, you might want to do that again, for instance. So this is also not only optimization, but it could be that the machine learns based on your past actions.
Yeah, and as you talked about, fraud and security, the anti-fraud approach, it seemed like you were describing what we call it, the exception detection or anomaly detection, detecting patterns or activities or directions of fund movements that aren't standard. It sounds like you were talking about some of that for the anti-fraud, but you also talked about erroneous trading. And so is this a built-in guardrails to help people from violating either a process or amounts or dealing with counterparties that aren't already set up in the system? What do you mean by erroneous trading? I guess maybe some examples of that.
Typically, clients do have, for instance, limits that they can't breach. But what happens if the limit is actually very high, or there is no limit in place for whatever reason? And then instead of entering a trade over, let's say, $1 million, you suddenly enter a trade of $10 million. And even worse, it's not a forward trade where you still have time to correct it, but it's a spot, for instance. And then if you're unlucky enough, you actually have a straight-through process attached to your system. So you immediately trade, maybe. And then you're trading, instead of 1 million, 10 million US dollar, and you can't do anything about it. So that's where erroneous trading is what I mean about that, so that you prevent, maybe really have something in between, that these kind of mistakes can't happen. Of course, typically you should have 4 eyes, 6 eyes in place to prevent that, but it might happen that it still goes through, nobody sees it, or another glitch that could happen, and this is where we see maybe a use case for machine learning to prevent these kind of errors to happen.
I like that. That straight through processing, speeds things up, moves it from one system to another more quickly. And like you said, if you make an error, you may not have time to catch it, and then machine learning rides to the rescue for the unintended consequences of an error in straight through processing. That it provides another, not a set of eyes, but a set of rules and learning that they can catch it. That's interesting. I really would love to hear you give us an update on where these projects are, maybe in 6 months or 9 months. I think it's just interesting to hear what you're doing on that. Just to summarize, how do you describe the value and possibilities of machine learning compared to some other opportunities in the Treasury space? Is these some of the best or middle of the road? How should we be valuing these? And therefore, how should that impact what we do and think?
I think the last years saw a lot of hypes coming and going. Bitcoin and was something, for instance, that came up. A blockchain was very hyped, but then the hype passed away. But I think here it is hyped at the moment, maybe, but it is in place for decades now. Machine learning is nothing new. It is here for decades, and it finally actually finds its way into the Treasury area, and we should embrace it and really should work with it. There are a lot of opportunities out there to incorporate it into the daily business, to make your daily business easier. And also what we saw in the past, new things are not always there to replace people. Sometimes, of course, it happened that people got obsolete, but I think here new areas will develop. So also Treasury is an ever-evolving area where if one thing gets automized, another pops up that requires the knowledge and the action of human beings. So we should definitely embrace the machine learning and artificial intelligence possibilities that we have for Treasury, work with it, understand it as far possible as it is, and and then focus maybe on other areas that you couldn't focus until now, but now is the time that you then really have the time to discover new fields of interest for you.
Very good. So the last question is, which is more important, robotic process automation or machine learning?
Well, in a certain way, both are artificial intelligence. As I mentioned in the beginning, robotics might also be a part of artificial intelligence, just from another perspective. For me, of course, personally, now I would say machine learning, as I'm working on it. I think it can go hand in hand, and the machine learning can actually maybe help to prevent erroneous trades by robots.
That's a very good answer. I like the summary at the end. Viola, thank you so much for your time and your input on this edition of the Treasury Update podcast.
Thank you for having me.
You've reached the end of another episode of the Treasury Update podcast. Be sure to follow Strategic Treasurer on LinkedIn. Just search for Strategic Treasurer. This podcast is provided for informational purposes only, and statements made by Strategic Treasurer LLC on this podcast are not intended as legal, business, consulting, or tax advice. For more information, visit and bookmark strategictreasurer.com.